Okay, so for this problem, we're looking at this picture again where we have this charged particle right here, and charged particle, and it's moving following the arrow. And so we know that when a charged particle goes into a magnetic field, um, we know this is out and this magnetic field is in, and we know when a charged particle goes into a magnetic field, it displays circular motion. And so we know from the problem that this radius is r1 and this radius is r2, and we know that r2 is equal to 2r1. So we know that I think from the previous problem they tell us this. So we want to find out which is true. So we want to understand the relationship between B1 and B2 and T1 and T2, where T is the time. So the time, what that means is how long is it spending in the B1 field and how long is it spending in this B2 field. So the first thing we know is that the force, let's write this up here, force, remember anytime you have an object that's in circular motion, right, the force is equal to ma, which is equal to m and then v squared over r. So that's the force for circular motion. We know that the force is always pointing towards the center of the circle, and so that means that it's perpendicular to its path. So at any point on here, if we drew the tangent line, the force is going to point perpendicular to the tangent line towards the center of the circle. So when you have a force that is perpendicular to the motion, you don't have any change in velocity. You only have a change in direction. So the circular motion just gives us a change in direction, and we learned that in first semester. And so we know here then the velocity in the B1 field for the smaller circle is going to be the same as the velocity here in the bigger circle. So what we can do, if we know the force for circular motion is mv squared over r, we also know that there's a force of a charged particle in a magnetic field, and we can set those equal. So the force on a charged particle in a magnetic field is qvb, right? And so we can solve for our r, right? So we can get an equation for r here. So we can cancel out our v's, one of the v's here, and we get, let's see, so we'll have mv over r is equal to qb. And so if I cross multiply, right, I'm going to get mv is equal to qbr. And so r is going to equal, I'm just going to divide both sides by qb, so I'm going to have mv over qb. And so what we can do then is we can say, okay, well, that's my r, so that's true for both of these cases. So now I can say r1 is equal to mv over qb 1, and r2 is equal to mv over qb2. And so if I want to write, I can use a ratio now. So I can say I know that that r2 over r1 is equal to 2. And I know that from this equation right over here, right, r2 is equal to 2 times r1. So if I rewrite this equation and say r2 over r1, I'll get 2. And so I can now plug in for my r's here. And so I know that r2 is mv over qb2, and r1 is mv over qb1. So my mv's cancel because they're the same for each of these, and my q's cancel. And so I have now 2 is equal to 1 over b2 over 1 over b1. And I can flip my fractions there. So I'm going to have 2 is equal to b1 over b2. And so looking at my equations here, I can see I have, I'm solving for b1. So b1 now is equal to 2b2. So that tells me 2b2. So that means I'm going to cross these two out. And so I have half the problem. And now I need to think about time. So if the velocity is the same in both of these cases, right? I'm gonna write this. Let's see. I think I can do it over here. So if my velocity is the same for both of these cases, I know that the distance traveled, right? So I've got velocity is equal to the distance traveled over the time. And so I know that's true. The velocity stays the same, but what about for this B1 when it's in B1? I'm going to have v is equal to 2 pi r1 over time. And I'm going to have, for the second one, I'm going to have, for this case, the B2 case, I'm going to have 2 pi r2 over, so this one would be time 1, and this one's going to be time 2. And so since they're equal, these two, the velocities are equal, I can set them equal to each other. So I can say 2 pi r1 over t1 is equal to 2 pi r2 over t2. And so my 2 pi's cancel, and I can solve for t, let's see, I've got t1. So if I cross multiply, I'm going to get t1 r2 is equal to t2 r1, and then that it follows from there that that t1 is equal to r1 over r2 times t2. And what does r1 over r2 equal? We'll look up here. r2 over r1 is equal to 2, so I flip that and I get 1/2 t2. So my answer is t1 is equal to 1/2 t2. So that's going to be this one, B. So 4 is B.